Hi friends, this video I'm going to explain about automotive CAN interview questions. This is part 3 video. Already I uploaded 2 videos which is related to CAN interview questions. Uh, Here, functionality of data link layer in CAN. So it have LLC, logical link control, and medium access control. In logical link control, you have to overload the control, notification, message filtering, and recovery management functions, etc. In Mac, you will do encapsulation or decapsulation, error detection and control, stuffing and destuffing, and serialization, deserialization, and everything you will do. So next one, what is hard and soft synchronization? Hard synchronization to be performed at every edge from recessive to dominant edge during bus ideal. So if you have any doubt on hard synchronization and soft synchronization, I just explained in depth in my old videos, that is CAN protocol in depth explanation. If you have any doubt about this, you just go and see there. Additionally, hot synchronization is required for each received send-off start-off frame bit, and start-off frame bit can be received both during bus ideal and also suspend transmission at the end of the interframe space. Any node disables hot synchronization if it samples an edge from recessive to dominant, or if it starts to send the dominant SOF bit. Two types of synchronization are supported here. One is hot. Hot synchronization is nothing but it is done with the falling edge on the bus while the bus is ideal, which is interpreted as a start off frame. It restarts the internal bit timing logic. Then soft synchronization, it is used to lengthen or shorten a bit time while a CAN frame is received. Next one is CAN error detection and fault confinement. So error detection, we have 5 types of errors, that is bit error, stuff error, CRC error, acknowledgement error, and form error. So you should know the errors and you should know the error introduced by transmitter or receiver. Every transmitter node reads back its transmitted bit from CAN line along with other ECUs, but if it will not get read bit same as it transmitted when the transmitted node stops the further transmission and introduce an error frame on CAN line, this error is known as bit error. Bit error situation, when this bit error will happen: if bit mismatch detected during arbitration field or acknowledgement, then the transmitter neither looks it as bit error nor introduce any error frame, because as per the CAN standard these fields has defined functionality. So next one is CRC delimiter acknowledgement end of frame are also fixed length fields in CAN frame. So it will also not be the part of the bit error frame execution if more than 5 consecutive bits found. Next one is stuff error. The stuff error introduced by receiver. More than 5 consecutive bits of the same priority in CAN frame between the start of frame to the CRC field is considered as a faulty frame on CAN bus, and it is signaled as stuff error on CAN line. Already I told, if it exceeds 1 1 1 1 1, again it will come here 0 dominant, but it continuously going 6 ones, more than 5. So this is a stuff error, and this error is introduced by receiver. Okay, next one is stuff error frame introduced after 5 consecutive recessive bits here. See. Next one is CRC, that is also introduced by receiver. The transmitter transmits CRC of transmitted data at CRC field of CAN frame, and the receiver also calculates CRC on the received frame. If the receiver found calculated CRC is different from the receiver CRC at the CRC field, then the receiver signaled it as CRC error and introduce an error frame on the CAN line. Next one is acknowledgement error introduced by transmitter. After transmission of CRC field of CAN frame, transmitter send acknowledgement a recessive bit and receiver makes and it dominant as a part of acknowledgement to the transmitter. During readback, transmitter found the dominant bit and consider it as a receiver acknowledgement, and if it reads a recessive bit, then transmitter signaled it as acknowledgement error and introduced an error frame. Next one is for error. As per the CAN frame format, there are some fields of fixed length and format like CRC delimiter, acknowledgement delimiter, end of frame, interframe space, and if it is detected corrupted at receiver side, then it's signaled as a form error and node will introduce an error frame on CAN line. So error confinement mechanism here. Here we have active error, passive error and bus off. If you have any doubts related to this, you just go and watch my old videos, CAN in-depth explanation. I explained everything there with the neat diagram. Here also I explained, but if you think that this content is not enough, you just go and watch that. In CAN network, every node is very honest. If any node transmits or receives continuously faulty frame, then it will disconnect itself from CAN network after a threshold limit, and if fault not required, the threshold limit will be 255. To decide this threshold, every node has two error counters: transmitter error counter TEC and receiver error counter REC. To keep the track of error generated because of above discussed situation, on this basis of these counters, nodes are categorized in these three states. First one is active error state. It 0 to 127 and receiver is also lesser than or equal to 127. Passive, TEC greater than 127 and receiver also, sorry, REC receiver error counter also greater than 127. Bus off is TEC greater than 255. If it exceeds more than 255, then it will go to bus off state. CAN error status active error here. A CAN node enters into active error state when TEC less than or equal to 127 and REC less than or equal to 127. Here this state node can participate in all CAN activity, like a node can transmit all types of frames like data frame, remote frame, overload frame and active error frame, 6 to 12 dominant bit. Next one is passive error state. Here also the passive, if it the TEC transmitter error counter lesser than or equal to 127 and this is also REC lesser than or equal to 127, then it's error free state. If it increases that, then the node can transmit all type of frames like, but it will data frame, remote frame, overload frame, but passive error frame on recessive state, active frame on dominant bit, it's for recessive bit. You should memorize this. And a node can come back into a error active state if it's start transmission of a correct frames and its counter value comes under 127. So after that, if the node start to give a current transmission and everything, so the value will decrease. Finally, the bus off. A CAN node enters into bus off state when TEC greater than 255. In this state, CAN node will be removed from CAN network and now it will no longer available on CAN network to participate in any activity. Then next one. Surely you will get these type of questions. Then what is the difference between functional and physical addressing? Functional addressing is an addressing scheme that labels message based upon their operation code or content. Physical addressing is an addressing scheme that labels message based upon their physical address location. So that is operation code or content, here physical location or source or destination. So this is the major difference here. Okay. What happen if I have to send more than 8 bytes of data? So according to J1939 standard has defined a method of communicating more than 8 bytes of data by sending the data in packets as specified in the TP, that is transport protocol. There are two types of TP. One is broadcasting the data, another one is sending it to a specific address. Here DTC consists of four components, that is SPN, FMI, OC and CM. Yeah, DTC is a combination of four independent fields, that is suspect parameter, SPN, suspect parameter number, yeah, then FMI, yeah, failure mode identifier, then OC, occurrence counter, then CM, conversion method, which tells that receiving mode how to interpret the SPN. Together, the SPN, all these things form a number of diagnostic tool can use to understand the failure that is being reported. So what is KWP? KWP 2000 is a diagnostic communication standard, specifies possible system configuration using K and L lines as 91412, but limited to the physical characteristics, specifies possible system configuration using K and L lines. Next,